Hello, everyone, and today we will be covering binary numbers. This will be the first video, or part one, of binary numbers, and today we will be discussing what are binary numbers, and we will also learn how to convert between binary and base 10. Okay, so what are binary numbers? Well, normally we would count in base 10, also known as decimal. This is because we have 10 fingers, right? So in base 10, we have 10 digits that go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. However, in binary, there are only 2 digits, 0 and 1. That's also why it's called base 2, because there are 2 digits. The reason why binary exists is because computers can detect whether an electrical signal is on or off. So it's very simple, right? There's only 0 and 1, and there's only on and off, right? Only 2 digits, 2 states. So 0 sometimes represents 0, obviously, and it also sometimes represents false, and it also represents off. 1 represents true or on. Also, each binary digit is called a bit. Okay, so now we'll go into expanded notation. Expanded notation is important for converting base 10 into binary, and vice versa. So the expanded notation of 5,321 is 10 to the third times 5 plus 10 to the power of 2 times 3 plus 10 to the power of 1 times 2 plus 10 to the power of 0 times 1. Now, you may notice these little numbers behind these tens, and you might not have seen those before. So these little numbers are called exponents, and they can be said in many different ways. So this 10 with a 3 exponent above it can be said as 10 to the third power, so 10 to the third power, 10 to the power of 3, or 10 cubed. But yeah, for now, I will just refer to these as 10 to the power of 3, 10 to the power of 2, 10 to the power of 1, and 10 to the power of 0 in the future. All right, so what is 10 to the power of 3, right? What are these exponents? Well, 10 to the power of 3 is 10 times 10 times 10. And 10 to the power of 2 is 10 times 10. So basically, 10 to the power of something is 10 times itself that many times. Anything to the power of 1 is just itself, and anything to the power of 0 is always going to be 1. Anything at all to the power of 0 will be 1. So 10 to the power of 3 times 5 plus 10 to the power of 2 times 3 plus 10 to the power of 1 times 2 plus 10 to the power of 0 times 1 is just 1,000, which is 10 times 10 times 10, times 5, plus 100, which is 10 times 10, times 3, plus 10 times 2, plus 1 times 1. And if you multiply all these together, it's 5,000 plus 300 plus 20 plus 1. And if you add them together, you get 5,321. So we're back to our original state, our original form. All right. So you can also use binary, or you can also use expanded notation for binary numbers. Say you wanted to convert this binary number, 110, into base 10. So something you may notice is this little 2 on the bottom of the number. That represents the base that it is in, right? So this is 110 in binary, not to be confused with 110 in base 10. Right? So this just ensures that you know what base you're working in. All right, so 110 into base 10, you want to do expanded notation, right? So first, you split up the digits. So 110 has the digits or bits 1, 1, and 0. And then you want to multiply by the place value. So this leftmost one is multiplied by 2 to the power of 2. And then this middle one is multiplied by 2 to the power of 1. And this rightmost and the 0 is multiplied by 2 to the power of 0. A pattern you may notice is that the rightmost digit starts with 2 to the power of 0, and then as you go on, the exponent gets 1 added to it. Something else you may notice is that this number under the exponent is the same number as the base, right? So in base 10, this little 10 is the one that has the exponent on it. But in base 2, the 2 is the one that has the exponent on it. Okay, so 110, like we said, is 2 squared times 1 plus 2 to the power of 1 times 1 plus 2 to the power of 0 times 0. 2 to the power of 2, or 2 squared, is equal to 2 times 2, which is equal to 4. 2 to the power of 1 is equal to 2, and 2 to the power of 0 is equal to 1. So this 110 is just 4 times 1 plus 2 times 1 plus 1 times 0, which is 4 plus 2 plus 0, which is 6. Okay, now you can pause this video and try these practice problems if you'd like. And if you get stuck, or if you finish, then resume the video and we'll work through it together. All right, I'm going to reveal the answers now. We'll start with A. Okay, so A says convert 1101 into base 10. So 1101 is equal to 2 to the power of 3 times 1 plus 2 to the power of 2 times 1 plus 2 to the power of 1 times 0 plus 2 to the power of 0 times 1. And something that I like to do is I sometimes start from the right side. So this, you can also say this as 2 to the power of 0 times 1 plus 2 to the power of 1 times 0 plus 2 to the power of 2 times 1 plus 2 to the power of 3 times 1. And this makes it a little easier because the exponent, you can just add 1 every time. So you don't have to, first figure out what your exponent is. You can just start from 0 and count up until you get to the end of the number, right? And again, this digit 1101, these correspond with these digits. All right, so now we multiply it together. 2 to the power of 3 is 2 times 2 times 2, which is 8. 2 to the power of 2 is 4. 2 to the power of 1 is 2, and 2 to the power of 0 is 0. So this is just 8 times 1 plus 4 times 1 plus 2 times 0 plus 1 times 1, which is equal to 8 plus 4 plus 0 plus 1, which is equal to 13. All right, now on to B. 1011 in base 10. First, you want to convert it into expanded notation, right? So the digits are from the right side to the left side. 1101. And that means it would be 2 to the power of 0 times 1 plus 2 to the power of 1 times 1 plus 2 to the power of 2 times 0 plus 2 to the power of 3 times 1. All right, and then that just equals to 1 times 1 plus 2 times 1 plus 4 times 0 plus 8 plus 1. And then that's just equal to 1 plus 2 plus 0 plus 8, which is equal to 11. So yeah, as you can see, you can go from right to left to right. Doesn't really matter, whichever one is easier for you. Okay. And to end off this video, you can check out this chart, and this chart will help you a lot in the future when you're converting or when you're adding, subtracting, and all of those things. So this just goes to all of the binary numbers up to 4 bits and their decimal equivalents. All right, that's the end of this video, and thank you guys for watching.